Hello, everyone. My name is Sipeng Liao, and I'm professor uh, at the UCLA, and I'm in the economics department. Today, I'm very happy to be here to give a lecture on the data science and machine learning in economics and finance. Let me share my slides with you. All right. Can you see my slides? Let me make sure. Okay, great. Uh, Now, today I will briefly talk about the economics and data science and the machine learning, and I will try to give a similar example and also illustrate why data science and the machine learning are useful in economics and finance. First of all, what is economics? So economics is all about decision makings of economic agents. Here, the economic agents could be individuals, and it could be firms, banks, government, and so on. So, for example, for the individuals, right, we may consider whether we should go to college, and we may consider which majors should I choose if I go to college, and we may make decision of whether we should go to graduate school, and whether we should go to a master program, and so on. For the firms, they also need to do a lot of decisions, right? For example, a firm, for example, may want to make decision whether or not to enter a new market, and a firm, say Apple, may consider whether they should introduce a new product, and the firm may consider a pricing strategy for the product, and they may consider an advertisement strategy on the customers. And for the banks, they may consider, right, so like loans and the mortgage, and they may need to make decisions on the portfolios, and they also need to manage the risk of the portfolios. And for the government is to make the decision of the fiscal expenditure, and also the need to make decisions on the other policies, for example, the monetary policy and so on. Economics is all about how to make decisions, optimal decisions for economic agents. And one key challenge in reality is the uncertainty. So that is in practice, we usually make decisions, and the decisions we make will affect the outcome in the future. And the outcome in the future will be uncertain, and it will be random. So this randomness is an uncertainty we're talking about. Because the outcome is uncertain, right? For example, if you buy a stock, right, so today, and you want to hold the stock for 1 month, then 1 month later, right, the return of your investment may be positive, may be negative. We cannot predict for sure whether we will definitely make money or we will definitely lose money. And this is uncertainty I'm talking about. Because of the uncertainty is involved in all decision makings for the economic agents. The probability theory is very important, and probability theory provides tools such that economists can use to study the optimal decision making under uncertainty. For example, using the tools from the probability theory, we can ask the questions, for example, right, what is the average or the expected salary if I get a PhD in economics? And what is the chance of a customer will buy a product if a advertisement is targeted on this customer? And what is the chance of their annual return of the portfolio is larger than 5% when the investment risk is under control? And we can ask, for example, what is the chance of the inflation rate drops 1% if the Fed increases the interest rate by say 0.75%. So using economic theory and the tools from the probability theory, we can ask questions like this, and we can make optimal decisions. Using all those tools, economists achieve a huge success in explaining socioeconomic phenomena and also providing guidance for decision making. For example, the Nobel Prize in Economics this year, 2022, is awarded to three economists, Ben Bernanke and Douglas Diamond and Philip Dybvig. So for the contribution of studying the financial crisis, and their classical paper is about the banking crisis, and they use the tools from the probability theory to build an economic model to explain the reason of the financial crisis. So the tools from the probability theory is widely used, and why they are used, that is because there are uncertainty about the decision making, about the outcomes of the decisions we make. Now, the economic theory is a lot of them are based on the probability theory, and then applying those economic theory will require data science. Why? Because although economic theory can be used to predict and predict behaviors, and it can be used to give us guidance on the decision making, but in reality, economic theory will be usually based on economic model, and economic model may contain some unknown, what we call parameters. And those parameters are unknown in practice. And if we want to use the economic theory and the economic models, we need to know the values of those parameters. And then how do we get those the values of those unknown parameters? One way to get the values is to use the historical data in our model, and we use the data to estimate those unknown parameters. And this is where the data science can be useful for economics and finance. So the data science will give us the tools to teach us how to estimate the unknown parameters in economic models, and it will give us tools to test the hypothesis for economic theory. And it will also give us the guidance for better decision making in reality. And this is very important because for economic theory, usually there are some parameters, and the economic theory will give different answers when the parameters in a model or in a theory are in different ranges of the what we call support. So if the parameter take different values, then the economic theory will give different answers. So in practice, we need to know in reality which range those parameters will be in. So that's why we need to use the data to know the values of those unknown parameters. And of course, we also want to know if there are competing economic theory for a same economic phenomena, we want to use the data to test which theory will be supported by the data. So this is why the data science is so important to us, because we need data science, the tools from the data science to estimate the unknown parameters in the economic models. And then we need tools from the data science to assess the uncertainty or the estimation errors of those unknown parameters estimated using the data. And that is very important in practice for the decision making. Let me give you a very, very simple tool example to illustrate the economic theory, decision making, and the application of the probability theory, and also to illustrate why data science will be useful. So let's say we have $100, right, in the bank account, and this $100 can be used to buy a financial asset. And we can also we just put this $100 in our bank account without doing anything. Okay. Let's say the bank pays no interest to this deposit. So if you save this $100 for 1 month, then at the end of the month, you get zero interest. So $100 is still $100. But if you buy a financial asset, then this financial asset will give you a return. But as I mentioned, this return in practice is usually uncertain, right? It's unknown because we don't know exactly what is the, say, monthly return of our stock, right, today. Because we don't know exactly what will be the price of this financial asset 1 month later, although we know the price of this financial asset today. So that's why the return is unknown, and we will treat this unknown return as a random, okay, which we'll call random variable in probability theory. Now, given we have two options, right? So we have many options, but given that we can save this $100 in a bank account, and or we can, use this $100 or a portion of this $100 to buy a financial asset, then we would like to ask the following question. That is, how shall we invest this $100 wealth? Okay. Now, if we want to study the return of the investment, then obviously we need to understand the randomness of this return of the financial asset. Let me make sure. Okay, so you're following me, right? So you can see my slides. Okay, that's great. Okay, just double check. Now, to understand the randomness of any investment, okay, so any portion of this $100 used to buy this financial asset, we need to understand the randomness of the return of this financial asset, because that is a source of the uncertainty of any possible investment as long as this financial asset is involved, right? Now, let's make this example as simple as possible, yet at the same time, it will capture the main feature of this whole theory. Now, let's assume that this return of the financial asset may take three different values, okay? So in this table, on the slides, you see like this capital R denotes the return of financial asset. It may take three different values. So it could be negative 0.05. So meaning that the return could be negative 5%. And it could be 0. And it could be 10%. Okay. So capital R may take those three different values with different probabilities. So capital R may take value negative 0.05 with probability 0.2. And this return may take value 0 with probability 0.3. And this random variable R may take value 0.1 with chance 50%. Okay, so this is very simple example, and in practice, of course, the return may take very complicated, which is totally different from the distribution of this random variable I display in this slide. But this is just a total example, as I emphasized, right? Now, given the return may take three different values, then we may ask, what is the average return of this asset? The average return of the asset is a so-called expected return of the asset. Okay, so it's expected value of capital R. So using this table, we can calculate the expected return. Okay, so it's essentially the values of the random variable may take, multiply the corresponding probabilities, and then we take the summation of these products. And then you see, like, with very simple calculation, we see that for this financial asset, the expected return is 4%. So 4% is the average return of this financial asset, okay? And we can also assess the risk of this financial asset by using the variance of this random variable. This is return, okay, capital R. So the variance of this return, capital R, can be also calculated using the values in this table. So the variance is 0.0039, okay? So those two values, the expected value of R and the variance of R, are two most important values for us to make our investment decision, okay? Now, let's say that we want, because we want to make investment, we need to have some goal, right? So let's say like we want to have an investment such that the investment will have at least 2% of average return, yet at the same time, the risk of an investment is minimized. Then If this is our goal, then we can ask what is the optimal investment strategy. Okay, and we want our investment to have at least 2% of the average return. Yet at the same time, the risk of our investment is minimized. Now, to answer this question, this optimal investment strategy, we can calculate expected return of any investment. Let's say that we use small x to denote the share of $100 in this investment. Okay, and then x share of the $100 will be in the financial asset. 1 minus x share of this $100 will be in the bank account, right? So the return of our investment will be x multiplied r plus 1 minus x multiplied 0, because you see, like, we have x share of the money in financial asset, right? The return from the financial asset will be x minus r, x multiplied r. And we have 1 minus x portion of $100 in bank account, which gives us zero return. So the return we obtain from the bank account is 1 minus x multiplied 0. So the return we get from this investment with x share of the money in the financial asset, 1 minus share of money in the bank account is x multiplied r. And r, again, is random, right? It may take 3 different values with 3 different probabilities in our example. As a result, the investment return, which is denoted as capital R subscript P, is also random. So we can calculate the expected value of the return of this investment, right? So it will be x multiply the expected value of R. So the expected value of the return of investment will be 0.04 multiply x. And then the risk of this investment will be x squared multiply the variance of capital R. So it will be 0.0039 multiply x squared. Okay. Now we have calculated the return, expected return of any investment, right, denoted by small x, and the risk of the investment represented by small x. And remember, our goal is to construct an investment with expected return larger than 2%, right? So we will require 0.04 multiply x is larger than or equal to 0.02, right? And then we want the risk to be as small as possible. That is, we want 0.0039 multiply x squared is as small as possible. And then you see, like, to have x to satisfy those conditions is very obvious that the optimal solution will be 0.04x equals to 0.02, right? That is, x will make this inequality satisfied, yet at the same time, the variance 0.0039 times x squared is minimized. So if we solve this problem, then you see, like, the optimal investment strategy is that x equals to 50%. So this means that we should put 50% of our money in this financial asset and the other half of the money in the bank account. And this will guarantee us to get expected return 2%, yet at the same time, the risk of the investment is minimized. Okay? So this is a very simple example to find the optimal investment strategy, okay, with a risky financial asset, right, and a risk-free asset. Here, risk-free asset is the deposit in the bank account. Now, you notice that here in this example, when we solve the optimal investment strategy, we have to use the distribution of the return of the financial asset, right? We have to use this table, and then we have to use this table to calculate the expected return of the financial asset, and we use this table to calculate the variance of the return of the financial asset. And then we can use those values to obtain the optimal investment strategy, right? So this is a decision making and uncertainty using economic theory and the probability theory. Okay? Economic theory here predicts, like, if we want to maximize the return yet at the same time minimize the risk, then we will choose the optimal investment strategy I just described, right? Now, in practice, it is always like for any returns, right? The distribution or the randomness of the return of a risk asset is unknown. Okay, so the mean and the variance of the return of their financial assets are unknown in practice. Then what do we do in practice? You see, like in theory, we can do really well, right? By assuming we know, say, like a mean and the variance of the financial returns. In practice, we don't know those values. But this is why, as I mentioned earlier, the data science can be useful. Because the data science tells us that we can use the tools from the econometrics and the statistics to use the historical data to estimate those unknown quantities. That is the expected return and the variance of the return of the financial assets. Okay. Uh, the tools from the data science can also let us to evaluate the estimation errors using the data to estimate those like unknown coefficients or unknown parameters. But why the machine learning algorithms are useful, given that we have tools from the data science to estimate unknown parameters in the model? That is because in practice, for example, if we want to construct a optimal investment strategy with not only one financial asset, we may want to consider investments on say 10 assets or say even on 100 assets, okay, which is usually the case for investment banks and large investment companies. Then if that's the case, then there are so many unknown parameters to be estimated to construct a optimal investment strategy. For example, if there are 10 risk assets, then there will be 65 unknown parameters to be estimated using a data set. And if there are 100 financial assets, then there will be more than 5,000 unknown parameters to be estimated to construct a optimal investment strategy. And because in practice the data is very limited, right? So we usually cannot estimate so many unknown parameters, and that is why the machine learning tools will be useful. So using the machine learning methods, we can, for example, select the most useful assets for a large pool of financial assets. And we can use the machine learning algorithm to uncover patterns among financial assets. And we can use the machine learning algorithms to forecast financial assets in reality. Okay, so this is why machine learning are useful nowadays in economics and finance. So to summarize, economics will use models to explain socioeconomic phenomena and provide optimal decisions, mostly under uncertainty. And data science will provide us tools from econometrics and statistics to estimate economic models and to make economic theory applicable and verifiable in reality. And machine learning will give us implementable and computational algorithms to enhance and automate the methods from the data science, particularly in the cases, when there are large models, a lot of parameters to be estimated with nowadays what we call big data. Okay. In the machine learning, there are three different groups of machine learning algorithms. There are unsupervised machine learning, supervised machine learning, and reinforced machine learning. Okay, so the unsupervised machine learning involves finding latent clusters or groups and achieving dimension deductions with a really large data set. Supervised machine learning will give us tools to predict a outcome variable with a lot of input variables. And the reinforced learning will give us tools to design to give optimal decision rules in a dynamic framework. Okay? So here, this is a picture of machine learning, three different groups of machine learning algorithms. They're widely used in practice to deal with different problems in reality. Okay, in the industry, the machine learning algorithms are widely used in the industry. For example, Amazon uses machine algorithm a lot, and Google and say Walmart, Target, and all the lot of companies are using these machine algorithms to to forecasting and to learn patterns and to assess the uncertainty of in reality and so on. And in finance, the application of the machine learning uh, gives rise the so-called fintech, so that the machine learning or the so-called artificial intelligence is very used in the finance and in many different aspects, as I show in this picture. Okay. So this is a brief introduction of the applications of machine learning in the business and in the finance. So at the end of my talk, I want to briefly describe the master program at the economics department at UCLA, which is our master of quantitative economics. So this is uh, a program run by the economics department at UCLA, and it is a STEM qualified. And the program UCLA is ranked really high in across the world, and the economics and the econometrics at our department is also ranked top 10 across the world. And this program attracts students across the world, and we emphasize the data analysis, and we teach students economic theory and machine learning algorithms, econometrics, time series analysis, and data analytics, and we emphasize the applications and the combination of economic theory and machine learning algorithms. We emphasize the application of those methods in reality. So the courses at MQE are taught by the mostly taught by the faculty members of the economics department, and the schedule is quite flexible. The student can complete the program in 1 or 2 years. Okay? And the students get the placement of this program is pretty nice, and 91% of students can find jobs within 3 months, as soon as they started to looking for jobs. And they'll find jobs in many different industries, for example, sectors, for example, the finance, banking, consulting, and so on. Okay. So in the last slide, I want to give you the link of the MQE program, and you can scan this barcode and to get the link to the MQE program immediately. Okay, so let me stop here for now, and if I have any question, I'm very happy to answer. Okay. So there are 2 posts online, and it would be great if you can finish those posts. Okay. Are there any question? All right. Thank you very much.